Okay, everyone, we're skipping lesson 7-1. After some thought, I realized that it's really not necessary in order to do the main point of these lessons, activity 7, which is really about factoring quadratic expressions. Now, quadratic expressions are a big part of algebra. So let's make sure we're watching the videos and we're taking our notes. So this lesson is about factoring quadratic expressions. Our learning targets are to factor quadratic expressions in the form x squared plus bx plus c, and this is when a equals 1. And just to let you know here, these are the same thing. These two targets are the same thing. And really, it should just be the second one, but because they're the same method. Just one's a little more difficult than the other. So the first one here, x squared plus bx plus c, is basically saying that that leading coefficient is 1. And the second one, it's when a is not 1, essentially. That's what we're talking about here. So when I say a, b, and c, we're talking about the coefficient of the quadratic term, which is the one with the square on it. And then the b is the coefficient of the linear term, which is the one without the square on it, with an understood 1. And then the last term is the c. It's called the constant term. It's called the constant term because it doesn't have an x attached to it. So a and b are what we call coefficients. They're the number in front of the variable. So like 2x squared. That 2 is what we call a coefficient. That's 2 times x squared. Okay, so we're skipping this part right here. I do want to make sure to point out the math term on page 107 is a quadratic equation can be written in the form ax squared plus bx plus c equals 0, where a is not 0. So that if a was 0, then there would be no quadratic term at all, and it wouldn't be a quadratic. It just wouldn't be. It would be linear then. An expression in the form ax squared plus bx plus c when a does not equal 0 is a quadratic expression. So here's the thing. Equations have equal to. It's equal to 0. An expression, notice the expression does not have an equal sign. It's just ax squared plus bx plus c. So I want you to understand the difference here. One's an equation and one's an expression. And for your chem chart, your memory clue, you could put this, 2x squared plus 3x plus 1 equals 0, where a equals 2, b equals 3, and c equals 1. And it has that equal sign. That equal sign makes it an equation. Okay? So we're moving on to the second page. And actually, I need you to think about the warm-up a little bit. So I'm going to go back to the warm-up for a moment because I worked these out for you in the warm-up explained video. Okay, so basically when we're factoring, we're going to rewrite these expressions as their factors. So the start here, these are the factors. We had x plus 2 times x plus 3. These are the factors. Okay, and then after we multiplied, and we got that answer, this is standard form. So factors are in the parentheses. Standard form is what you get after you multiply. And when we multiply, there's a pattern that you should notice. Look at the numbers in the original and compare them to the standard form. So the 6 came from 2 times 3, and the 5 came from 2 plus 3. So the numbers that are in the factored form directly impact what our result is. 2 times 3 gave us 6, 2 plus 3 gave us 5. So the C term is the product of those two, and the B term is the sum of those two. So like for example, here's another one. If I had x squared plus 9x plus 14. My factored form is going to involve the numbers that multiply to give me 14, but then add to give me 9. So I want you to pause the video for a moment and think about what are two numbers that multiply to give you 14, but then add to give you 9. Okay, you should have figured out that it was 2 and 7. So I could break up that 9 into 2 plus 7x. So then our answer would have to be x plus 2 and x plus 7. And we can work this out to check it. X times x gives us the x squared. X times 7 gives us the 7x. 2 times x gives us the 2x, and 2 times 7 gives us the 14. And when we combine that and simplify it, we'll get the thing that we started with. So the answer is technically this guy right here. Those are the factors. But we can check it by multiplying them back together. And by the way, this is the easy way when a is 1. A equals 1 here. This is a simpler version of the problem. And that's where we're going to start. So I'm going to go back to the textbook now. Okay, so this is one way to do it, using boxes. So basically it's saying, think about area. You know, when you find the area of a rectangle, it's length times width, right? So you can think of one side as the length and the other side as the width, and you have to multiply them. Inside is length times width. That's what we're working with here. Our answers are going to go on the outside of the box. And basically, I think, what do we have to multiply together on the outside to get x squared? Well, that has to be x times x. And then, it's missing something. These two in the middle, those two empty boxes, we're looking for what adds together to give me my middle term, my 12x. So I'm looking for two numbers that multiply to give me 32, but then add to give me 12. And so this is where I make what I call an ACB chart. ACB. Our A is 1. Our B is 12. And our C is 32. So A is 1, C is 32, and B is 12. I'm looking for two numbers that multiply to give me 32 and add to give me 12. Those aren't zeros, by the way. Those are supposed to be circles. So this is when the number game starts. Factors of 32. Well, that could be 2 times 16. So these numbers have to multiply to give me 32 and add to give me 12. But 2 plus 16, that's 18. So that's not going to work. 4 times 8. Okay, that gives me 32. 4 plus 8. That does give me 12. So the numbers I'm going to use are 4 and 8. So if I put 4x here and 8x here, those both add up to 12x. And then I'll put, so basically 8 times x is 8x. And the 4 will go here because 4 times x gives me 4x. So our answers are on the outside. X plus 4 times x plus 8. And it breaks it down a little differently. It says list factor pairs of 32. And that's what I did here. Okay, in my table, I did 2 times 16 and 4 times 8. Those are factor pairs of the constant term, which was the 32. Choose the pair that has a sum equal to 12. That's what I did. 4 times 8 equals 32, but then 4 plus 8 equals 12. So that's what they used here. And then they put the 8x and 4x right there because those two add up to 12x. And so our answers are on the outside. I'm going to do lots of examples like this. So we say our answer is x plus 4 and x plus 8. Okay, so before I do these next examples, I want you to answer this. Okay? Describe in your own words. Describe how to find the missing numbers. And what by that I mean, how did I find the 4x and the 8x? What did I do to find the 4x and the 8x? Describe how to find the missing numbers.